Yes. So first of all, I'm Dave McAllister. I'm a senior technical evangelist. I work in the observability group at Splunk. Um, I've been doing the computer stuff for a while now. The mention of Linux early on. I started Linux with version 0.93. Late 90s, I was one of the more active business speakers around the world for why Linux was going to become important. Since then, I've done tons of things. I've worked for large companies, small companies. I've been product managers. I've been a CTO. I've been a CIO. I've started my own company, which we sold, but I still consider it to be an abject failure for this. But Splunk also always has these things around everybody's a million points of data. So let me share 3 with you real quick here. 1, I'm married. I have a witness that I do not read minds. So feel free to ask your questions. I will try to remember to breathe between slides. Feel free to interrupt me. 2, I spent 10 years as a soccer ref. I am used to people disagreeing with me. In fact, I can guarantee that every call, half of the people on the field would disagree with whatever that call was here. And finally, 3, I'm going to buy 3 cats. I am completely used to being ignored. So, I can see your little faces over on the other side here. And if you look like you're writing email or something like this, I'll let you get away with it. And in person, I'd walk over to you and look over your shoulder, but I can't do that here. So let's step into this discussion around and particularly into OpenTelemetry. But to do that, I need to sit. And the first one is this thing called observability. We're even talking about tracing it is because we now have this thing that's come into being, that new hot buzzword of observability. And data is the driving factor for observability. What kind of data can vary across the board, all sorts of data inside of there. But think about it this way. What happens if you didn't get all the data? Or you missed ephemeral data? Or your data showed you something that you couldn't go back and dive into, or you only saw the good stuff or the bad stuff. So data starts off this. But the reason it becomes important for this observability is that we have now moved into a very different world between both our infrastructure and our applications. First of all, a lot of things, once we move into the cloud native type environments, or as we move that way, is we're in microservices. And microservices create very complex interactions. Microservices, as defined by me, are not as small as possible, but are as small as necessary for this. But they still depend on communication pathways, sharing of information between them. Because of that, we end up with the second point. Our infrastructures are now elastic and ephemeral. They may not be there when we go to look for them, and they may not be in the same place when we go to look for them. And therefore, our failures don't exactly repeat. Therefore, once we get into this debugging, multi-tenancy in particular, is really painful. And monitoring, as we understood it before, is now changed. We can't keep monitoring the same way we did, where we could go walk down the row of servers and look at the ones with flashing lights on it to say, oh, everything's working fine. So I love this little thing. It's called the Cynefin framework over here. And there are 2 technologies that come into play here. When you look at this from the monolithic one server, one application space, we were pretty simple based. We sensed, we categorized what the errors were, and we responded to it. And that was kind of the best practice model of this. Microservices make things more complicated here. Therefore, now we need to be able to do that sense the same way, but we've got to analyze in different forms, and our response may be different on that. Our elastic ephemeral moves us into chaotic. Things are not the same. Things change constantly inside of here. And therefore, there's an action that revolves to our sensing, that revolves to our response in here. And finally, as we merge these 2 places, we want to get up into this new comms environment where we are probing. We are asking questions. We're sensing what the data and the analysis were, and we're responding to it. This is kind of where we are today in observability. We're in this emergent space where the data comes into play. The one thing, by the way, is you don't want to try to shortcut across the middle, because the middle is going to give you disorder for some time. You need to be able to work with both of these pieces as separate pieces to be able to make sense of what the complex environment's going to finally look like. So here's a sample microservices architecture. This is a pretty traditional e-commerce type environment. There's a front end coming in from the internet. I can have synthetic load generators testing this. I order things, I look them up, I make recommendations, I send cart service to it. But what happens is that front end now talks to a lot of different services, and it can talk to them simultaneously. So it can send off to a cart service at the same time that it's sending off to an ad service. It can be pulling, the checkout service can be talking to a currency service, which could be reporting back to the front end, back out to the internet. And so this is a very simple drawing. But for instance, if you think about current AWS UK on an Amazon web page is 57 front-end microservices, each backed with somewhere between 4 to 8 additional microservices behind it, just to give you an idea of what the complexity now looks like. So when we now do this, we need to know how that transaction walks through the system. And we get into this thing called distributed trace visualization. Distributed because it's spread between multiple services or functionality. By the way, I use the word microservices a lot here. It doesn't mean that you have to be written in microservices. It means that you have to be able to understand the functionality and break it apart at that level. But the front end came out, checkout service to place an order, currency service, shipping service. And each of those pieces is ordered in time to give me an order functionality, as well as in a duration functionality. And this gives me a tremendous amount of information about what's going on with my application. And from there, I can figure out what's going on with the infrastructure and pair the two together. So tracing concepts are really simple. There's kind of three here. There's a span. A span represents that single unit of work in the system. A functional completion is a span. The span is all work together, and the spans can hand off to different pieces inside of here. A trace is defined by its spans. A trace can be thought of as directed acyclic graph, where the edges between spans are the parent-child relationships. So if you look at the top, it's a little hard to read probably, but the top is the trace. And inside that trace, you can see where the spans came into play, how long the spans are, and where the spans themselves are made up of children's spans. You can see how that pulls together as well. There's also what's called distributed context, which tells me the identifiers, the tags, any options that I want to pass to this, because the trace by itself is interesting, but not necessarily informative. So simply putting it this way, a transaction by microservice, the microservice by its functions, passing to another microservice, that's all a trace is. And the whole thing happens over a time period. And we track the order, as well as the time across which things have occurred. You can, of course, generate microservices from a trace as well. And in general, you'll hear this called RED, rate, error, duration, which is the ability to look at how many things are coming through, whether there are any errors, or in how long on an aggregate basis. But for instance, you could change and push a new front end. That front end suddenly comes up with 5 times the number of requests. That front end is not going to report an error, but your CPU on checkout service is probably going to show that the CPU pegged at 100%. And however long that mattered becomes across here. Checkout doesn't have an error. It's pegged, but it doesn't have an error. Front end may report an error because it's not being able to push the request through here. And so therefore metrics being generated off of this give me the first step into what this looks like. Similarly, logs can come into play here. And you can connect logs from multiple places. So for instance, the checkout service may show me an increase in 503s that's actually being caused by a mail service problem. So this is just a quick little setup for the rest of what I'm going to spend some time talking about. Oops, come on, go forward. So the next thing is that we hear this word observability a lot. Observability is a lot like the word open. It means whatever who is talking to you means it to mean at the time they're talking to you. In my case, observability is the data that lets me do aggregation, analysis, and response. And so it's all around the clarity of what I'm looking at. It's not the tool, it's the environment that's giving me the data. And because of that, we have data collection. And data collection covers a lot of things. But first of all, I'm a firm believer that data should be standards-based, agent-wise. It should be cloud integrated inside of here. And we need to avoid data lock-in. We've managed to get away a lot with having to deal with programmatic lock-in. Not perfect. I can still tell you programs that live on my wife's computer that don't run anywhere but on her system for this. But as long as I can avoid the data lock-in, I always have the ability to move to a tool that provides the functionality I want. We also, when we start looking at this tracing environment, we want some other pieces to come in place here. We want automated code instrumentation. The last thing you want to do is go hand code tracing data into every single application. You may want to hand code some, but you don't want to do it because every time you change it, you're responsible for those changes. We also want to support any developer framework, and therefore no rules need to apply inside of that. My experience with microservices is that our applications were written in the appropriate language, not all written in a single language here. We want to support any code, and we want to support it at any time here. And then finally, the last one needs a little bit of a stretch, which is that we don't want to have cardinality limits. Cardinality is that tagging information that we add to this so that we can slice and dice to figure out that the slowdown happening in the card service or the checkout service that was reported by the front end, API front end, was actually being caused by a noisy neighbor problem that was living in a pod on top of my Amazon EKS. So the cardinality is what lets me do this. The better, the finer grain you have your cardinality, the faster you can get to the underlying structure. So don't limit me on cardinality. And so we finally get to the point of what we're talking about, OpenTelemetry. So OpenTelemetry is a project that came into being because we had two competing open source projects. Open Tracing, which defined the nature of what we wanted to be able to do with tracing, but didn't define how it was processed or provide libraries to it. We also had a project out of Google called OpenCensus. And OpenCensus defined what tracing structures should look like, as well as providing the libraries to do that work. The two groups got together in March, I think it was March of 2019, and agreed to form OpenTelemetry. So OpenTelemetry is the next major version of both OpenTracing and OpenCensus. And if you're using one or the other, there's full backward compatibility. You can continue to use it and feed it into your OpenTelemetry system. It also supports some of the former ones, Jaeger, Zipkin. It also has the capability of dealing with metrics, and we're in beta for logs. I'll cover that a little bit more. But it becomes a one-stop for the three principal classes of data that we pull together when we're looking at applications and infrastructure. OpenTelemetry just recently reached the 1.0 on a specification. However, both Open Tracing and OpenCensus were production-ready systems when they started this work. And there are a tremendous number of companies that are already using OpenTelemetry as their basis for this going forward. So the nice things are, this is also an open source project under the Cloud Native Computing Foundation. It is the second most popular program that's going on inside of CNCF. Splunk is a founding member via its acquisition of Omnition, which was one of the three companies on stage when OpenTelemetry was announced. For this, we are committed to this. We are the largest contributor. And in terms of the engineering capabilities, we have also provided specific intellectual property, just made it freely available to use, including the smart agent capability that came out of SignalFX, as well as the logging specification, which came out of Splunk itself, which became the driving factors for what's going on. So these two pieces become really important. we're all in on OpenTelemetry. And as of, sorry, let me think which day, April 15th, when we announced our brand new series of products, when we released our brand new series of projects for this, quiet, the announcements next week for this, OpenTelemetry is the collector for the projects. And so this is now another commitment level that we are so committed to this that we are moving ahead now. So when we look at this, there's a word telemetry in here. And telemetry is how we collect data for this. And when we come to cloud native in particular, which is a lot of the driving factors for this functionality, there are certain things that come into place here. First of all, there are what we call verticals. And these are the classes of data. There's trace and there's logs. Likewise, we can have these layers of horizontal functionalities, and that's the instrumentation, canonical representations, the data infrastructure, as well as the interoperable formats. For each of these pieces, you want to have this crossed. So for every language of interest, you want an API that does instrumentation for you. For every language of interest, you want a canonical representation. You want your data structure to be able to cross all of the data collection models here, be they collector agent bases, be they sidecar bases, all those different pieces need to come into play here. And then finally, one of our major commitments is that this is all interoperable. You should not have to change your data to be able to get your data in. And by the way, we also like the capability, I'll explore a little bit more, that should you choose to change your data, you can send your data out in any form you want as well with no loss of data. It becomes really, really important in being able to take this into environment. Fortunately, OpenTelemetry is pretty much already in this space. And I've forgotten what the specific date is this year. Early in, I want to say January, we did release 1.0.0 of the specification for this, for trace, the context, and what's called baggage, what's get carried along with this. This was the driving point for this, and this has allowed us to make rapid progress on a number of different pieces inside of that. And I'll talk a little bit about language and where they are as well as we get into this. So, architecture. Lots of components, as you would expect for this. There's the API, there's software development kits here, and then there's the data spec itself for this. There's also a collector, and the collector is vendor agnostic. Now, each vendor can choose how they represent it. And so, for instance, there is a Splunk supported OpenTelemetry collector. You download it, you get support from Splunk, the same way as you would get this. We're not alone in that. I'm just happen to work for Splunk, so I'm going to say that for that model, but it's vendor agnostic. You get to receive data, process data, and export data to your heart's content here. And it is the default way of collecting the data. If you choose to write directly, you can, but this is the best way to do this, is the easiest potential to start up here. We have client libraries. All instrument application libraries are there. We have support for traces and metrics inside of here. We have automatic trace instrumentation as well. Logging, the specification was adopted last October, November, something like this. It's in beta format. So where we are right now, traces is 1.0. Metrics are in beta. We expect to go 1.0 very shortly, where we're waiting on traces that expect to go in there. And then a handful of the languages are Erlang Go. But Java is a 1.1 spec, .NET is 1.0, and Python is 1.1. You can always go check the specs. The github.com under the OpenTelemetry project has all the latest information of what's going on with the specifications across all the languages, the collector itself, and probably 20 or 30 other pieces that I don't pay as close of attention to as I probably should. But nonetheless, this gives us the ability to start looking at various things. So here's the reference architecture for this. You have an application that's running on a host. That host can be virtual, it doesn't matter. You have a collector inside of here. The collector talks to the host environment and to the library that's living with the application. This library is the auto instrumentation library in this case, or you can hand code, but not recommended for you. The agent collects that and then can send it forward to any number of backends. And in this case, I'm looking at one backend is receiving traces and metrics. The other backend is just receiving metrics. Same functionality coming in. This can also change. You can also have a service collector. A service collector is something that collects a number of different agents together and then forwards it on. So if you're working in a on-premises environment, this is the best approach, is to bring a service collector into the middle of this and then be able to, in a sense, isolate it and open the port specific for it without risking the rest of your environment. Same concept, application, host, collector, talking to this, sending the information as required. Now, in OpenTelemetry, spans can be freely created. It's up to you to figure out what attributes you want to assign to them. Some of these things we see so much that we just assigned these. And these became what are known as semantic conventions here. HTTP methods are supported, and you will see HTTP information. It's just tagged onto you automatically. Databases are the same way. Messaging systems, be they Kafka, be they MQTT, be they AMQP, whatever, simply get tagged with what the system was, what it is. And then as a service, Lambda, for instance, or Microsoft functions, the trigger is automatically tagged to each of the trace pieces of information.
Actually,
this all happens for you automatically.
Real quick, you may want to repeat like the last 30 seconds because it was pretty garbling. Your connection just broke up there.
Yeah, sorry about that. So to OpenTelemetry, spans can be created freely. It's up to the implementer to do that for this. When we have certain well-known protocols, and this is a short list, there are others in here, we automatically tag information to it. HTTP, what its method was, what its status was. So if HTTP reports a 503, it's tagged into your trace for here. Databases, messaging, be it Kafka, be it MQTT, AMQP, whatever gets tagged to the system and the destination. Notice it is not the origination, it's the destination. The origination is determined by the span for this. And then function as a service, the trigger itself is always tagged into this. So these give you a start on some of that cardinality capabilities here. So when we see these pieces, we automatically tag them. You can choose to filter them out, but we in OpenTelemetry automatically tag with that information. You can then add more stuff to this, and this is something called a span event. So span events, think of them as context-aware logging. Information you want to have the span know when you're dealing with this. And it's, again, time-stamped to when the span portion occurs, what is happening at that period in time. So think of this as a structured log, a JSON log. So by minimum, it contains the name of the event, the attribute, at least one attribute, and a time. You can expand this as large as you want it to be. And so, for instance, here's an example. Using Kubernetes pods, I'm using Google Cloud Functions on this. So in the pod environment, I need the container image name. I have an image tag that goes along with this. I have the cluster name, the namespace, and on down this. You can see each of these pieces. This is included so that each has this type of information. Cloud function, we're into FAS. So we have an ID, the name, the cloud provider that's doing this, where it lives, and these become our semantic conventions for this as an example. This is data that helps you when you look at a trace environment, figure out what the underlying infrastructure looks like. So this is roughly speaking, kind of what sort of happens as a simple graph as I could pull together. Thanks to Kevin Brockhoff for doing the hard work on this. So each of these pieces is in a Kubernetes deployment. So I have a Kubernetes cluster. I have node. I have pods that live inside of this. I have namespaces, and I have the kube system namespace. Each of these pieces can communicate through different functionality, be it a Prometheus model. I can pull in data via Grafana. It can export data to nodes. It can pull data from those nodes. It can talk to a collector, and the collector can talk to each of those microservices out to the collector service, and then report them all out to whatever. There's also a Jaeger collection inside of this as well. What that actually looks like over on the right-hand side is my services. My traces are being received by OTLP, which is the trace protocol here. I am including with that what the processors, memory limits, resources, etc. I'm asking for specific metrics, Prometheus metrics via OLTP for this. I want to know what the processors are doing inside of that. And likewise, I can now go down and look at this and how they align with this. So for each of these traces that happen inside of the system, I am going to receive as a minimum the context that's showing over on the right. You can continue to expand this context as much as you want to. Most of this is actually in YAML file structures. When you get started, this is always the major question: how long is it and hard is it to get started? Well, if you are in something like Java or .NET, it's drop the automatic trace library in place. Just put it in place. In this case, looking at Java, I put the Java piece in place. I instrument all the known libraries with no code changes. These are runtime conditions. There are a couple of things that are important. It will adhere to the semantic conventions that are set up here, but it does not look inside of functionality the same way that you could do by expressing this a little bit deeper for the library structures. However, depending on the complexity of your system, knowing the endpoints is probably the most important part. You don't necessarily need to know what's going on inside of the service unless the service has a lot of different function pathways here. It can exist with your environmental. It can exist with runtime variables in here. It can coexist with manual instrumentation. Do not, and we live with this one a lot, do not use too often auto instrumentation solutions on the same service. I would love to say simply that your mileage may vary, but let me put it this way: you will be broken. Don't do this. So if you already have an auto instrumentation solution that you're happy with, we'll approach that from a different viewpoint. Otherwise, you can change to this one. Keep in mind that all the updates are now happening in OpenTelemetry model.
So Dave, I have a question there, because we use Sentry. We don't use Splunk right now, but is Sentry moving toward the OpenTelemetry model of things as well? Or if I want to get on OpenTelemetry, I need to move into either using the open source versions of the products or using the Splunk versions of the services?
The answer is a qualified maybe yes.
Yeah.
Sorry to do that. And I get a little bit, and I've got a slide a little bit that talks a little bit about the architecture. You can, even choose not to do that because of the nature of the collector, you could bring it in one format and export it back out to the Sentry format. I believe Sentry has stated interest in OpenTelemetry. I can't remember ever seeing anybody at a meeting, and I haven't seen any information that's coming out that makes me be able to say one way or the other. So your mileage may vary a little bit, but the OpenTelemetry is really kind of nice in being able to let you to slide around that hoop a little bit.
Okay.
So let me check, make sure, sorry, time check in my system. Okay. 13 minutes, 27 slides still to go. So let's step a little bit into why tracing for this. So tracing is all built around this concept of what problems you're trying to solve. And this is a little tiny bit of possible answers. You could be looking at performance issues. We live in an instant gratification society. Google study, 3.7 seconds means somebody is likely to bounce off your web page. 3.7 seconds for that. Much maligned Microsoft study, 8 seconds is human attention span, which means that you're taking too long. You need to know what's going on for that. Mean time to resolution and detection can be too high. logs and metric information you need in here. And being able to provide more data may give you better answers. Like I said, very short set. There can be lots of other things, but this is my set I put here. And why it became important is that we've moved from, even in the last 3.5 years, we've moved from this observability of 1.0 to 2.0. We used to bring in logs to one thing, and then metrics to one thing, and traces to one thing, which meant trying to correlate between the three to figure out what the heck was actually going on got to be really a challenge. And we had to manage 3 different library sets, 3 different spaces in our application space, each of which had their own updates and structures. And we still see this a lot. There are a lot of 1.0 models here, even if they're coming from a single company. The OpenTelemetry model said, we know what data we want to come in here. We want logs, traces, and metrics. Plus, by the way, we want anything else that you can think of to be able to brought in here. We want it all to go into the same collector so that it correlates correctly here. And then once we have the correlated telemetry, we want to be able to send it to the backends of interest. Again, your data structure becomes unified. Your backend is your choice. And this is sort of back to that Sentry question here. Your backend is still your choice, but you don't want your data to be able to cross the boundaries and stay together. And so what was happening is basically couldn't figure out what was going on between what was going on for this. And because the data was in different formats, you couldn't necessarily say that this data was being caused by this event or even the timeframes. There's lag and skew that happens inside of here. We also have a bunch of people say, hey, I've been doing this for a long time and I'm not sure that it's working for me. Let's try something new. And so we do see these 3 as principal reasons for here. And when we looked at this, we also started looking at this and saying, why do people care? And it became, so who's going to benefit from this? What we see in this model for OpenTelemetry is that we are seeing tremendous benefits in things like detection and response, not resolution, but response coming out because the data is now correlated here. We're also seeing the developer environments be able to cross into this and get resolutions quicker because all the data is now available to them. We also looked at this and said, how hard is this going to be? Back in the early days of Jaeger and Zipkin, it was not unusual for it to take a full year to put tracing into an application. I mean, it was not unusual for it to do that. And then last, what's your short-term goal? Do you just want to know what's happening with your transactions? Done. The auto instrumentation libraries for you here. If you're using it, are people using it? And what are the possible roadblocks? And then finally, why do you want tracing now? If you're in e-commerce, you've answered that pretty quickly here. If you are the SRE, the engineer or the IT guy, what kind of questions do you have, and can it help you when you're doing this? And how can you filter out the noise aspects when you determine what's going on inside of that? And I don't have one of the slides I really wanted to put up here, so I'm gonna talk my way through it in just a second for this. This relates back to Calvin, your comment. So the OpenTelemetry collector is made up of a series of ingest side and an exporter side. And in the middle is the processing capabilities. The processing capabilities can be batch processing, can be streaming processing, but can also be logic processing. So for instance, you could bring in OLTP model and process it through and send it out as OLTP, or send it out as OLTP, or send it out as OLTP, Jaeger, and Prometheus. You can bring in Prometheus metrics and send them out through OLTP. Those edges pieces, there's a set of those that we consider to be core. And the ones that we consider to be core are the open source ones. But that means that there's a lot of other pieces inside of here. And we have, if you go out to OLTP community or collector community, sorry, I forgot which, you will find 50, 60, 100, I haven't looked recently, of people that have written these exporters, importer-exporter models to pull the data in from a different format and send it out from a different format. These are plug-in modules The collector simply knows that, oh, you suddenly want this. You specified in your YAML file what your pathways look like for this, and now you can get your data. So if you're bringing in data from OLTP and you're going to just send it out to, say, Sentry, you would need a Sentry exporter. I think that's the right word. I'm losing my mind here all of a sudden here for this. If it doesn't exist, this is an open source world. Hopefully somebody's published what they're looking for, and you can probably get it created yourself. If not, go talk to the company and ask them why they're not following open source. And if you need backup, I have a nice baseball bat someplace I can loan you for that. So anyway, that's the model of what you're looking at here. Is we want to make sure that data is never locked in. And by locked in, we mean that you're not even locked into OLTP as a format. You get to use whatever format you want to use. It may be some coding on your part, but you can always do it. And this becomes a major difference in OpenTelemetry versus anything else that's out there. No data lock-in.
So this brings to a question about like the exporters and how you actually send your data through those pipelines. It seems like one way is you can actually put those metrics into your code directly, or some kind of add-on to whatever framework you're using is going to be able to like send those metrics. What about like structured logging, or like say sidecars on containers that are then doing the instrumentation for you? So there's kind of three different ways I see that you could do this.
Right. And so again, a sidecar model, think of it as a sidecar collector agent model. It can be sending directly to your backend. But if you're in a really a true sidecar model where you are keeping track and you're simply setting them up when you set up pods, you're probably going to send them to a service. The sidecar model can do the data adjustment for you with its components, or it can send it to the service, which does it for you, or you can do it inside. The reason that you don't want to do it inside is that within the next 2 years, it's probably going to change. Something is going to change on you one way or the other, and you're going to need to be able to update that. You don't want to necessarily update your code. Rule number 1, if it ain't broke, don't fix it. Rule number 2, if you touch it, you will break it. Rule number 3, it's going to be expensive to fix it. Okay, so keep those pieces in mind. If we're using this exporter conversion model, we're actually just replacing the fuse. We're replacing the piece of pipe for this. And it's more in my world where I live in California. So from about now until next November, if we're really lucky, there's no such thing as rain. And so I've got to make sure my irrigation system can water my garden. I started with PVC. Can you imagine what it would be like if I had galvanized pipe to run my irrigation system? So I have PVC. I now have little plastic pipes with drip tubes. And fixing it is like, oh, look, a little bit of duct tape done for this. This is, I hate to use the phrase duct tape model, but this is a very simple model for you to be able to keep up with. And by the way, if you do this, when the collector changes to next version, you're automatically done. You don't have to do any additional work inside of that. So that becomes really an important thing. So what do you want to trace? Well, sorry, background in data science and statistics. Give me all the data and I'll figure out what to do with it. You may not want that. And in fact, that may not be your right thing. So keep in mind what you want information on. You may not care to know what goes on past a certain service, or you may not care to know more than, oh, the service received the message correctly and returned a satisfactory answer here. Keep in mind why you want to trace in the first place, what problems you're trying to solve. Rule of thumb, start with the service boundaries. This is what's called endpoints, and start with third-party calls, where you call out to databases, where you call out to other things. Service meshes are a major player in that space here. It's iterative. Add to it as you continue. There is information overload, but that's actually usually a responsibility of the tools to be able to aggregate, analyze, and provide you the visualization to allow you to respond. And so information overload is not about the amount of data you're receiving, it's the amount of data and how you're approaching your viewing of that data here. And finally, if you're doing this for a company, make sure that your tracing is basically free or almost free for the teams that are using this. Again, auto instrumentation is a great benefit for this. And so, kind of summing up here, observability drives this thing that we now call evidence-based debugging here. Debugging of these complex systems is iterative. You start with high-level metrics. I spend my life in red, rate error duration. That's probably what I do all the time. In fact, at Indy Cloud last year, I did a talk on red. That's my favorite subject to talk about for this. You want to drill down and detangle based on that fine-grained data. So you want to be able to drill in and say, oh, look, errors are running at 51%. What the heck is going on? You want to be able to drill into that. And once you've got the evidence, you can make the deduction. And finally, to close out for this, we'd love you to come join us. Even if you just come check stuff out here. The project, OpenTelemetry.io, will get you started inside of here. We do have a Gitter community on OpenTelemetry on the community here. You can join a special interest groups. There are several dozen at least out there. And then consider submitting a PR. Good first issues and help one another out that. With that, thanks for listening to me today. And let me unshare, and where did my share go? There we go. And if there are any questions, I know we're at time, but any questions that come up.
Yeah, I mean, huge thanks, Dave. I'm super interested in this, so I hope the folks have some questions for you. They should ask them because there's.
I have a question.
Go ahead, go for it, Greg.
All right. So some of the systems that OpenTelemetry could push data to provide like a view of this week's data, and you can overlay it with a view of last week's data. So is that baked into like the OpenTelemetry data store, or is that really dependent on the vendor? Like, is there going to be some kind of industry standard to be able to view those two timeframes on top of each other?
So what I think you're talking about is what's called historic comparison, and that is not baked into telemetry specification. However, there is a tremendous amount of discussion going on around how we analyze and visualize data. So historic comparisons, believe it or not, the biggest issue is what is a successful historic comparison? Is it the last week? Is it the last month? Is it December versus December last year? And this is why it becomes vendor specific, is how long the data is retained.
Okay. Yeah, I mean, that does matter too, right? Because it could be the last deploy, like the last week before the last deploy, and you want to see if you've made meaningful changes in performance of your application or something like that.
Yeah, we actually, so again, one of the things, we have alerts, triggers that are set up that show changes of what we call sudden change environments, which are, I think I've got them set at 5 sigma, at 5 standard deviation between what I see normally. I also do historic tracking, and I do historic tracking of I think a week versus week and month versus month. So what was this 30 days ago? What was this last week at this time frame? There's also a seasonality element, which is not quite as easily automatable. What did this look like last Black Friday versus this Black Friday, which becomes another aspect of that.
Had to go find the mute button. Any more questions for Dave? I mean, it's tracing. Cool. Tracing is an interesting problem, right? Because once you have all this massive amount of data, now you're making it super easy for us to get lots and lots more data. Now making it actually like usable, interesting, and like seems like the industry standard for the visualization of this data has been Grafana. But Caleb can commiserate with me on this one. Is that Grafana is just such a pain in the butt to maintain. It's almost a full-time job of maintaining just the configs and keeping up with the changes as they change that platform. So maybe, I don't know, maybe that's a question actually. Is there a better way?
So yes, and of course I do work for commercial vendors. So let me bring this up here. Having lived through DIY, DIY is great until you attempt to scale.
Yeah.
If you're doing this for one system, it's fine. If you're doing this for currently, I think the underlying SignalFX structure is about 2,300 AWS instances. If you try to run it across that, you're going to end up with some interesting headaches here. Grafana, I spent a lot of time with Grafana in my former company for this. The problem was the Grafana was really great at certain things, but it wasn't, polite way of phrasing it, wasn't fast enough. I'm sorry. I live in a real-time streaming world for this. I want to know when things happen now. AWS Lambdas, a Lambda warm start is 30 milliseconds. Average Lambda execution is about 1.2 seconds. If I don't see data until 10 seconds to 30 seconds post that point, how many executions have I missed? And that becomes a problem. And so I like my things to be streaming. I am sorry, I'm a need for speed guy. That's bottom line. The last thing is that you also, analytics are really, really important. And as cool as I think our solution is, the SignalFX analytics solution is really got everything you can think of. You want linear regression? By God, it's there, okay? I will guarantee that somewhere, some data scientist has a different model. And so what we did was we built the analytics to support this Python-like language. The like piece is because Python allows you to basically overwrite your namespace, and variables can mean different things at different points. When you're working in statistics, having variables mean different things at different points doesn't work. And so variables in, let's call it signal flow, are actually locked in place for that. But you can write what you want to. If you want to write the Krups-Seinfeld linear modeling for prediction, go for it. It's pretty straightforward. And again, having that analytics language backing your visualization tool makes a huge amount of difference.
Awesome. Yeah, I didn't mean to set that
Cool.
as like a softball for Splunk necessarily, but it does make sense that if you've got serious scale problems, maybe you should talk to some serious people who just that's their thing they do.
Well, and you hit us spot point, because I just posted a blog on SignalFlow, which is the analytics language of choice. So I'm deep into, oh wow, look what I can do next. So your timing was spot on to really get my hot spots going.